Hi, in this video we're going to talk about regression. Now regression is just a fancy word for fitting a line or another curve to a set of data that you may have. So for example, if I had, say, weight over time of some growing animal and I made these observations, okay, you can see that they don't fit exactly on a line, but what regression analysis would allow me to do is come in here and approximate the best fit for this line. All right, so we use regression to fit a straight line to our actual observed data points. Now, it may go through one point exactly, but it will not go through all points because we're fitting a straight line to data that is probably a little over or a little under at times. In this class, we're going to strictly limit our discussion to linear regression, which means we're going to fit a straight line. But keep in mind there are other types of regression, like quadratic, or we can fit any type of curve we want to data, but the most common is to use linear or a line. Now, in your previous classes, you may have seen the equation of a line as y equals mx plus b, and if you recall, m represented the slope or the steepness of the line, how quickly it increases, or keep in mind it may also decrease. That's the slope. And then B represents our y-intercept. In other words, if we take our line and draw it all the way back to where x equals 0, our y-intercept is the point at which the line crosses the y-axis. Remember that this is the y-axis. This is the x-axis. The y-intercept may or may not have meaning when you're doing regression analysis. If time 0 has meaning, then it may. If time 0 does not have meaning, then it may not. So for example, this should represent the weight of the animal when it was born, right? Time 0. All right. When we move to our regression analysis in statistics, we change the form of this line just slightly. We typically write it as y equals b sub 0. This is just saying this is the 0 parameter plus b1 x. Okay, so this in reality is what used to be called just our b, and this in reality is just our slope still. So keep in mind, if you're asked for the slope, remember it will be in front of x. And if you're asked for the y-intercept, it will be the number by itself, okay? So it may be written in this form, or it may be written in this form. So why do we do regression analysis? Well, if I've made these observations over time and I can fit a line to it, then I can use that line to make a prediction. So for example, if I wanted to know an estimate of the body weight here at this time, then I can plug in this value into the equation and it will generate a best guess of what the weight would be at that time. So for example, here, if I wanted to know a value at time x equals 5, I could plug 5 in for x and generate y. So in other words, I'd say y equals 2 plus 1.5 times 5, okay? 1.5 times 5 would give me 7.5 plus the 2. So my best guess would be 9.5. Okay. So we can make predictions. Now keep in mind a regression line is only legitimate, all right, for making predictions if our correlation is significant. And we covered that in the previous video on correlation. In other words, if we have a significant correlation between our two variables, then it's legitimate to make a regression curve and then make predictions with that regression curve. If our correlation is not significant, we can fit a regression curve, but it won't be legitimate to make predictions with that regression curve. So now I'm going to show you how to generate the regression curve. There are all kinds of complicated formulas to doing this, but I'm going to show you how to do it in Excel. If you watch my correlation video, then you'll have more background information, but you'll also see that we had generated these graphs, winning percentages versus points scored by team, winning percentage, points allowed by team, winning percentage, points differential for our NFL teams in the year 2017. And now I'm going to show you how to fit a regression curve and generate the equation. You have to first generate your scatter plot, which we've done here. Again, remember to generate the scatter plot. You highlight your data, insert, go down here and click scatter. Okay. Once you have your scatter plot, you want to click on your data, and then you can right click and do add trend line. All right, one more time. Click on your data, make sure they're highlighted like these are. Right click, add trend line. And then you get your choice of trend lines. Like I said, you can fit an exponential, logarithm, polynomial. We're going to use the linear in this case. It actually defaults to the linear, so you really don't have to do anything up there. But what you're going to want to do is click down here, display equation on chart. Once I get out of there, you can see my regression equation. And now it's giving it to me as y equals mx plus b. If I was asked for b naught, I would say 210.96. If I was asked for the slope, 272.89. And that is my regression equation. So how could I use that equation? Well, for example, if we wanted to know how many points scored by a team with a 10% winning percentage, then we could come over here and use our regression. We could say 272.89 times 0.1. I'm filling in 0.1 for my x value in this equation, plus 210.89, and it will give me a prediction. It's saying if you only win 10% of your games, you're probably going to score about 238 points. Okay. All right, let's repeat the process for our other two graphs. Again, to generate the regression curve, we click on our data, right click, add trend line. It defaults to a linear line, which is great. We just want to make sure there's a check by display equation on chart. And when we exit out of here, we have our equation. Notice here that our slope is negative, and that again reflects the fact that we had a negative correlation. As our winning percentage increases, the points allowed by the defense decreases. And notice that this is negative 177.15. All right, one more time, click on our data, right click, add trend line. Make sure display equation on chart is selected, and it will appear. So that's how we can use Excel to generate our regression equation. Again, the first step, which I did not show you, is to have your data in a scatter plot. It does not work if you have a bar chart or any other type of chart. So you want to make sure you go to Insert and select the dots right here, Scatter.